Hi all. In this video, we begin a discussion of chemistry. As we saw in Chapter 1, all material things, that is, matter, things that have mass, including living organisms, are built from chemicals. That means gaining an understanding of chemistry can help us understand many other things. Why do we get bedhead? How do our muscles fire? And of course, most importantly, what causes the foamy milk in lattes? We'll start with a discussion of atoms. Atoms are the basic units of matter. Different kinds of atoms interact with one another to form chemical systems that can take on amazingly different characteristics. For example, if you take the chemical called sucrose, table sugar, and you heat it up too fast, you get nasty, charred, black, burnt stuff. But if you take that same sucrose and you heat it up more gently and patiently, you can produce the wondrously sweet, smoky, complex stuff called caramel. Delicious emergent properties of the atoms that make up sugar and oxygen, plus the right amount of heat energy. Atoms are tiny little things. I once heard the scientist Neil deGrasse Tyson estimate that the human body is made up of 3 septillion atoms. That's this number. When I think about all those atoms packed into my one little body, it makes me think that the whole pizza I just ate wasn't that big a deal. Or maybe it was a huge deal. I guess it depends. Anyway, back to the topic. Atoms themselves are made up of 3 even smaller components: protons, neutrons, and electrons. Compared to each other, protons and neutrons are relatively big, and electrons are incredibly tiny. This picture isn't really accurate. If protons and neutrons were the sizes they are in this picture, the electrons would have to be about 1,000 times smaller, dots that would be too small for us to see. Protons and neutrons pack together to form the atomic nucleus. The number of protons in the nucleus determines the kind of atom we're looking at. This picture shows the periodic table of elements. The elements are the kinds of atoms that exist. Each box in the periodic table gives information for a different element. You can see some familiar names. In the upper left box is hydrogen. In the upper right box is helium. There are 119 elements that have been discovered. Fortunately for us, only a couple of dozen are found in living organisms, and of those, only 6 are present in large quantities: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. There's only one thing that all atoms of the same element have in common. It's called the atomic number, which is the number of protons in the nucleus. All carbon atoms that have ever existed had and currently have 6 protons. All nitrogen atoms have 7 protons. All hydrogen atoms have only 1 proton. Protons are positively charged. That means they are energetic, and they repel one another, because like charges repel. In fact, if an atomic nucleus has too many protons too close together, it can blow apart, a nuclear explosion. Fortunately, packed into the atomic nucleus along with protons are neutrons. Neutrons are uncharged. They act like referees, keeping protons from getting too close to one another. Atoms can lose neutrons over time. So atoms of the same element, that is, they have the same number of protons, can differ in their number of neutrons. We call atoms of the same element that differ in the number of neutrons isotopes. There are some uses of isotopes in medicine and in scientific procedures such as carbon dating. But in the lives of organisms, isotopic variation tends to be pretty minimal. So we'll leave our discussion of isotopes here and we won't discuss them anymore. Of more biological importance than differences in neutrons are differences in electrons. We'll pick up with that discussion of electrons in the next video.